Welcome back to my channel. In this lesson, we are continuing with the topic atomic structure. If today is your first time of joining us, we welcome you specially. Remember, this is a place where we learn the basics of chemistry step by step. Please do well to check our previous videos. So by the end of this lesson, you should be able to answer the following questions. So get your writing materials and let's get started. So we are considering a subtopic, electronic arrangement under atomic structure. So what is electronic arrangement? Electronic arrangement is the way electrons are distributed in the shells around the nucleus. You can say the way electrons are shared in the shells around the nucleus. Remember in our last class, we said nucleus is the center of an atom and it consists of protons and neutrons, while electrons move around this nucleus in shells or energy levels. So let's look at the rules that guide the way we share the electron, or rather distribute the electrons in shells around the nucleus. First, we should know that the first shell holds maximum of 2 electrons. The second shell holds maximum of 8 electrons. And the third shell holds maximum of 8 electrons for the first 20 elements. So for the purpose of this lesson and at this level, we are going to be considering just for the first 20 elements, and also we are going to be stopping at third shell. We are going to be stopping, please note that we are going to be stopping at third shell and also for the first 20 elements for the purpose of this lesson. Now let's look at the examples. Now we look at the elements. Hydrogen, atomic number 1, number of electrons 1. The electronic arrangement is also 1, meaning that hydrogen has a number of electrons 1 and is going to have 1 shell, and that 1 shell will have 1 electron, because 1 electron can still fit in, is not more than 2. For helium, rather, the number of electrons of helium is 2. That means it's going to have 1 shell because it is not more than 2. So the 2 electrons is going to fit into the 1 shell. For lithium, we have 3. It's already more than 2. So we're going to have 2 shells for the lithium. The first shell will contain maximum of 2 electrons, and the second shell will contain 8. For beryllium, we have number of electrons of beryllium 4. So it's going to also have 2 shells. First shell will have or contain 2 electrons maximum. The second shell will also contain 2 electrons, which is the remaining. Now for carbon, we have 6. I'm just picking randomly now. We have 6. So we are going to have 2 shells also, or carbon is also going to have 2 shells. And these 2 shells, how do we share the electrons? We are going to share it 2-4. First shell has maximum 2 electrons, and the remaining 4 can still fit into the second shell. Remember, we said the maximum electron for the second shell is 8. Now for neon, which is 10. So we are going to also have, neon is going to also have 2 shells. How are we sharing these electrons? It's going to be 2, 8. 2 maximum for the first shell and 8 maximum for the second shell. So it means for the 11th element, which is sodium, it's going to have 3 shells, which is 2, 8, 1. Hope you're following. Now you can do for the rest of the remaining 20 elements, that is from magnesium to calcium. Now let's look at the structure properly. Like I said, this is the structure of the carbon. As we said, carbon has 2 shells immediately after the nucleus. This is the nucleus here, the center of this element or this atom. Now it has 2 shells maximum in this first shell, and the second shell has 4 electrons maximum, as you can see. So it means that the electronic arrangement of carbon is 2,4. So you can see how we shared it in the shells around the nucleus of that carbon. Hope you're following. And let's look at the second example. Sodium. Like I said, sodium has 11 electrons. Now the electronic arrangement is 281, meaning the first shell immediately after the nucleus has 2 maximum electrons. The second shell already has 8 maximum electrons, so the one that is remaining is going to be at the third shell. So this is the electronic arrangement 281. Now before we call it a day, let's look at valence electrons. We cannot just go without talking about valence electrons. Valence electrons are the electrons in the outermost shell of an atom. The electrons in the outermost shell of an atom. For instance, as simple as it stands, that is what it is. When you look at the electronic arrangement of carbon, you see that it is arranged 2,4, meaning that 4 electrons is what is on the outermost shell electron, which is the second shell. If you count the electrons in the outermost shell of this carbon, you see that it has 4 electrons at the outermost shell, meaning that the valence electron of carbon is 4. Valence electron of carbon is 4. So you can, from the same way, get the valence electrons of other ones. For instance, the valence electron of hydrogen is 1. The valence electron of sodium is also 1. The valence electron of magnesium is 2. The valence electron of lithium is still 1. So you get the valence electron by arranging it and knowing the electron that is at the outermost shell. So we'll be stopping here for this lesson. Before we go, let's quickly answer the questions we saw earlier. Number 1, which subatomic particles are found in the nucleus of an atom? A. Electrons and protons. B. Protons and neutrons. C. Electrons and neutrons. D. Protons, neutrons, and electrons. And the answer is protons and neutrons. Only protons and neutrons are found in the nucleus of an atom. Number 2, an element has electronic arrangement 281. How many valence electrons does the element have? A. 1. B. 2. C. 8. D. 11. So the valence electron here is 1 because 1 is the electron found in the outermost shell. Now, an element has 13 electrons. Which of the following represents its electronic arrangement? A. 283. B. 265. C. 284. D. 281. So you try this and write or leave the correct answer, whichever one, in the comment section. Thank you so much for watching to this point. I believe you've learned something. Please, if you have really found this video helpful, please do well to like, subscribe, and share. You can actually be helping someone, especially that child that is complaining that chemistry is hard, by sharing this piece of video with someone. Thank you once again. We'll see you in our next lesson. Bye.